Good morning children. Beta, today we are going to start our new topic, that is surface area and volume. Okay. And what is this in this chapter, surface area and volume? Just try to understand that. Beta, in this chapter we are going to learn about the 3D object. Before this, in the previous chapter, while we have learned about the different types of coordinator, at that time we have learned about the different types of means 2D object we have learned. What is the difference between the 2D and 3D object? 2D objects are those objects in which only length and breadth are there, like our pages. Okay, that is 2-dimensional. Okay, and 3-dimensional objects are those objects in which we have length, breadth and height. For example, I am going to show you 3D object. Okay, see that this is a 3D object. Okay, it is a cubical box. Here length, breadth and height almost they are same. Little bit of difference maybe, but if we will see that it is near about a cubical box. Okay, so in this object you can see that we have, this is length, okay, breadth and height, okay, depth. These kinds of objects are known 3D objects. What are the examples of 3D objects? Cube, cuboid, cylinder, okay, cone. These are the examples of 3D objects. In your syllabus only we have cube, cuboid and cylinder. Okay, we are going to learn about these objects. Example of right circular cylinder. We have, you will learn in this chapter about the right circular cylinder. For that, I am showing you one glass. Okay, this is the example of right circular cylinder. What do you mean by right circular cylinder? If we will see its height, okay, see that right circular cylinder means, first of all, I am going to write your chapter name, surface area and volume. Surface area and volume. Okay. In this chapter, we are going to learn about cube, cuboid and cylinder. Okay, cube, cuboid and cylinder. Now, cylinder means, if we will take a, it is better a circular, it is a rectangular sheet. Okay, you know that it is its length and this is its breadth. Okay, so what do you mean by the, if I will take a rectangular sheet, for example, this is a rectangular sheet, okay, and its length is L and breadth, this is its breadth. If I will fold it along its length, see that this length is folding. So if I am folding this means rectangular sheet along its breadth, so what kind of object we are getting? See that. What object we are getting in this way? If I will fold this, you can see it. Okay. It was its breadth. I am mentioning now. It was its breadth, and this was length. So if I will fold it, you can see that we are getting a right circular cylinder. We are getting a right circular cylinder in this way. You can see this. Okay. So if I will fold it, you will get a circular cylinder in this way. It is the object becoming like this now. So what beta? This breadth is becoming its height now. Okay. And this length is becoming its circumference, that is 2 pi r. Circular objects, it is becoming its circumference. Okay, it is a circular. See that it will become like that. Circular object, circular base. So its circumference will be 2 pi r. So what will be its CSA, curved surface area, will be 2 pi r h. 2 pi r h. 2 pi r this and multiplied by height. So it is becoming CSA of the cylinder. Okay, so maybe everybody of you have understood this. Okay, first of all I have started from the which part? Cylinder, 2 pi rh. Okay, now if we will take 2 pi rh means beta, if it is only a circular means circular cylinder. Okay, it's here bases are not there, here the bases are not there. Okay, so if we will cover this base, we will make a circular, cut a paper like that and we will stick it here, so it will become a circular, means it will have the bases, it will be covered by from two sides of its bases. So at that time it will be a object which will have the bases also. Okay, which will have the bases also. See that but lateral surface area, try to understand the lateral surface area. Lateral surface area means, just now I taught you that we have made a right circular cylinder in which you can see that in this cylinder top, base, top, and see that from the open and from the top and from the base it is open. Okay, here the base and bottoms are not included. Base and bottoms are not included in this cylinder. That's why it is known as the lateral surface area of the cylinder. Which formula we have understood just now, that lateral surface area, which is CSA, or we can say that lateral surface area also, LSA or CSA, both are same thing. Lateral surface area means in which top and bottom, you can see that when I have made this this cylinder, at that time top and bottoms are not included in this. You can see that from the bottom is also it is open and from the top also it is open. Okay, so it is for this kind of cylinder, what will be our formula? Lateral surface area or total means curved surface area, both are same thing. It means this formula will be 2 pi r multiplied by height. 2 pi r multiplied by height, circumference of the base multiplied by height. It is known as the lateral surface area of the cylinder. Okay, now second thing means total surface area. Total surface area. Total surface area of cylinder is equal to lateral surface area plus area of two bases. Area of two bases. Okay. Now see that beta, lateral, what is the formula for lateral and what are the shape of the bases? Circular bases are there on both the sides. And what is the area of the circle? See that lateral surface area will be beta 2 pi rh multiplied by plus area of two bases. Two circular bases I am writing. Two circular bases. Okay. And what is the area of circle? Pi r square. And how many circular bases are there? So it will be 2 pi r square. Now if finally by combining, if we will generate the formula, what will be? 2 pi r is common, so take 2 pi r as common. What will remain here? H. And what will remain here? R. So it will be the total surface area of cylinder. TSA of cylinder. TSA of cylinder. Okay. TSA of cylinder is equal to 2 pi r and in bracket H plus R. Lateral surface area of cylinder will be 2 pi RH. What is the difference between the lateral surface area and total surface area? Again I am repeating. Lateral surface area means in which top and bottom are not included. Okay, means from the top and from the bottom also they both are open. Okay, and in total surface area it will be a closed cylinder. Right, that you can see that beta, this is a glass. Here only one base is there. From the top it is open. So in this case, if we would like to calculate its total surface area, we have to cover it from the top also. Okay, you can see that the cylindrical closed object while you are getting cold drinks in a cylindrical object, at that time it is coming. Okay, what are the cold drinks like that? Coca-Cola and those kind of while you are taking na, those in they are coming in the cylindrical objects also. If I would like to find its area, so what it will have, beta? You can see it is a glass. Okay, only one base is there. If I would like to calculate the area of this object at that time, what I will do? Area, it's means lateral surface area means, beta, area of this part, okay, which you are able to see. Okay, area of this circular part will be 2 pi RH, or plus area of only one base is there. So it's means if I would like to find the area of this object, so what I will do? Area CSA of the cylinder plus area of one base. Here only one base is there. From top it is open. Okay, and for the total means if top and bottom both are included, at that time its area will be lateral surface area plus area of two circular bases, and its formula will be 2 pi r and bracket h plus r. And now I am going to find the area of this kind of object. Okay, now see that area of a circular cylinder with one base, okay, like for example base, for example a glass. Okay, at that time what will be its area will be 2 pi RH plus area of one base, area of one circular base. Plus area of one circular base, and what will be its area, beta? 2 pi RH plus circular base means only one circle, pi r square. Okay, so what will be, if I will take, here we cannot take anything common, only pi can come common, so no need to take anything as common. So whatever is there, in this way you will put the values and you will get the answer. Okay, so it was the cylinder, it was the all the formulas we have taken for the cylinder. Again I am repeating, means if you will fold a circle, means a rectangular sheet, then you will get the object like this, and that will be the cylindrical object. Okay, it was its length. When you are folding, it is becoming the circumference of the cylinder. Okay, and its breadth is becoming its height. Okay, that I have mentioned here. So in this case, here top and bottoms are not included. From both the sides it is open. So in this case, what we can find? Lateral surface area or curved surface area of the cylinder. Curved means it is become a round object, na? It is becoming a round object. Okay, so lateral surface area will be 2 pi rs. Now in the second case, beta, if the top and bottom from the both sides, if we will cut a paper sheet again and we will cover it, we will close them, then it will become a closed cylindrical type, closed cylindrical object, and at that time what we will find? Total surface area of the cylinder. Total surface area of the cylinder. And for that, what will be its formula? Lateral surface area means, lateral means, beta, this one. Whatever the area of this sheet, it will become, while we are folding it, it is becoming a round sheet. That's why it will be a lateral surface area. Okay, na? Lateral surface area, previously what was its area? For this rectangular sheet, its area was length into breadth. If we are folding it and it is becoming a cylindrical object, then length into breadth will be equal to 2 pi RH. लेंथ इंटू ब्रेथ किसके बराबर हो जाएगा? 2 पाई आर एच के बराबर हो जाएगा. क्यों हो जाएगा? क्योंकि जब हमने इसको खोला, काटा, इसको फिर से कट करेंगे तो ये फिर से रेक्टेंगुलर शीट बन जाएगी, एंड अगेन इफ वी विल फोल्ड इट, इट विल बिकम अ cylindrical object. So if the top and bottom will be included, lateral surface area plus area of two circular bases, and it will be 2 pi r h plus circular means area of one circle is equal to pi r square. Here two circular bases will be there, then its area will be 2 pi r square. So 2 pi r will come as common and in bracket it will remain h plus r. Okay. Now if the only one circular base will be in the cylinder, at that time what will be its area? Okay, 2 pi r h plus area of one circular base. So it will be 2 pi r h plus pi r square. So with the help of these formulas we can calculate the TSA or CSA of the cylindrical object. Okay, now we are going to learn about the cube and cuboid. Now see that beta, I am going to show you this object. It is also almost a cube. Okay, how many faces are there? कितने फेस हैं इसके आप देखो, 1 2 टॉप एंड बॉटम. ओके, 3 4 5 and 6. I am going to close, coming to close, you close the camera. See that 1 2 3 and opposite face 4. This 5 and 6. You have seen dice now. How many faces are there in dice? 6 faces. And it is an example of a perfect cube. Dice is an example of a perfect cube. Everybody of you have played snakes and ladders. At that time, everybody of you have seen the means cube. Okay. So see that beta, in cube all the faces are of square shape. Every face is of square shape. Okay. So if I will make a figure of a cube, it will be look like this, because it is a two-dimensional figure. Okay, two-dimensional. I am making in a blackboard, and blackboard is a two-dimensional shape, so it will not be come in a 3D shape, but we are trying to make it. Okay, how we are making in your copy or in a blackboard, it is coming like that. See that beta, it is an example of a cube. Okay, how many faces should be there? Here we can count that 1 2 3 4. Okay, 1 2 3 4 and 5 and 8. One face will be at the back of this one. Okay, so 6 faces will be there. Okay, see that all the faces. What will be the area of one square? Suppose every side. Now if you will see that all the sides are of A. Suppose its length is A. So what will be the area of this face? A square. So area of this face will also be equal to A square. Area of this face will also be equal to A square, because all the sides are of same length. Area of this face will also be equal to A square beta. And here also A square or A square. So how many faces are there? 6 faces. So what will be its total surface area? Every face is having a square shape, and every face having area A square. How many faces are there? 6 faces. So what will be its area? 6A square. See that beta? It is an example. Suppose it is a square. Okay. See that square I am making. Okay. Its side is A. So its area will be A square. Okay. So how many faces? TSA of cube, total surface. TSA means beta total surface area. Total surface area of cube is equal to area of 6 square faces. Okay, area of 6 square faces. So first area of one square will be A square plus A square plus A square plus A square plus A square. Okay, 1 2 3 4 5 or 6. So how many A square it will be? 6 A square. So 6 A square will be the TSA of cube. TSA of cube. Okay beta. If suppose here top and bottom are not there, if I will remove this top and suppose I have extruded this bottom also, suppose that bottom is also not there, top and bottom are not there, so what will be? At that time you will find lateral surface area, LSA of cylinder. LSA of cylinder. What do you mean by the lateral surface area, beta? In lateral surface area, I am writing here top and bottom faces will not be included. Will not be included. Okay. So how many faces will remain? If I will remove this top and bottom face, then how many faces will be there, beta? See that 1, 2, 3 and 4. Only 4 faces will be there. So lateral surface area of cylinder is equal to area of 4 faces. 4 faces, that is a square plus a square plus a square or plus a square. What will be? 4a square. 4a square. Okay. For example, see that I am standing in this room. Okay. And suppose the roof and bottom, roof and this means floor is not included. So what will remain in this room? Only 4 walls will remain. So only 4 walls will remain. Okay. So if it will be a cubical room, at that time top lateral surface area means, if we will see the example of a cubical room, so it will be a area of 4 walls. Area of 4 walls of the room, and that will be equal to, if it is a square shaped room, then its area will be 4a square. Okay. Now if suppose, for example, beta, we have taken this time that top is not included. You can see now it is open from the top. This box is open from the top. So if we would like to find the area of this box, so what will be? Area of a cubical box without top, means top is not included. So how many faces will be there? You can see that 1, 2, 3, 4 and 5. 5 faces will be there. So what will be? Area of 4 faces plus area of base. Area of base. You can see that, beta, area of 4 faces was 4a square. A plus area of base means that will be a square. So it will be 5a square. You can write it as 5a square. So if we know all these things, so if we have understood the introduction part of the chapter, then we will not have any problem to understand the topic. So see that this means introduction part of the video very carefully, so that you will not have any problem while we will solve the exercises. Okay. Now we are going to learn for the cuboid. Now beta, we are going to learn about the volume of cube. Okay. One last formula that is remained, that is volume of cube. Okay. Volume of cube. You can see that I am having this box. If I would like to find its volume, so what will be its formula? Length multiplied by breadth, okay, and multiplied by its height. Volume of cube is equal to length into breadth and into height. And here length, breadth and height all are same. Okay, all are same, because it is a square shaped object, so its length will be a, multiplied by breadth is also a, and height is also a. So its formula will be equal to a cube. Okay, meter or centimeter cube. Meter cube or centimeter cube, depends on that in which unit we have to given the numeric values are given in which unit, depends on it. Okay, so here we have learned for the cube. Same things will be for the cuboid. What will be the difference between cube and cuboid? Here all the faces have equal length and breadth and height, but in case of cuboid beta, what we will have, length, breadth and height, all three will be of, means different measurement, of different measurement. Now see that we are going to understand about the cuboid now. Now see that beta, I have made cuboid. In cuboid, all the faces will be of rectangle shape. Rectangular. For example, if you will see that this is an example of cuboid. Okay beta, here see that it is a cuboid. If I will close this box, it is a cuboid, and see that all the faces are of rectangle. Okay, 1, 2, 3, 4. See that this is also in rectangle shape. Okay, this face is also in rectangle shape. This one face is also in rectangle shape. So all the faces are of rectangular shape. Okay, so if I would like to find its area, means TSA of cuboid. Here also see that beta. If I would like to, first of all, one more thing I would like to introduce before that. See that it was a box. Okay, and how many, see that how many sides it was having. See that beta, how many sides it was having? 4 sides here. Okay, 4 sides in the base. How many sides are there? 8, 9, 10, 11 and 12. How many sides will be there? 12 sides. How many faces will be there in cube and cuboid? 6 faces. 1, 2, 3, 4, 5 and 6. You can also count them. Okay. And how many vertices? Vertices means corners will be there beta. See that 4 corners at the top and 4 corners at the bottom, and other than no corners will be there. So how many vertices will be there beta? 8 vertices. Again listen. How many vertices in cube and cuboid? 8 vertices. How many edges or sides? 12 sides. And how many faces? 6 faces will be there. Okay. Now see that total surface area of cuboid is equal to, how many faces was there? Area of all 6 rectangular bases. Rectangular bases. Okay beta. If you will see that, okay, if suppose I will take an example, okay, it is an example of cuboid. What will be its area? Here it is length and this is breadth, and it is, this one is height. Okay, height of this book. It is a shape of a cuboid. So if I will take the area of this part, so what will be? Length into breadth, and same area will be of its opposite face, length into breadth. So area of L into B plus L into B. 2 length into breadth will be there. Okay. If I will take the area of this part, here beta, length is there and height is also there. So area of this rectangular base will be length into height, and same area will be of this face also, length into height. So plus L into H plus L into H. Okay. This part and this part we have taken. Now we are coming to this one part. Here breadth is there and height is there. On same thing will be here, breadth and height. Okay. So plus B into H plus B into H. Now you can see that all the 6 faces I have included. So what it will be? L into B, L into B. How many times? 2LB plus 2LH plus 2BH. Now I am arranging them in a proper sequence. 2LB plus 2BH plus 2HH. Okay. So TSA will take 2 as common. Okay. So what it will become beta? 2 length B plus BH plus HL. It will be the total surface area of cuboid. Total surface area of cuboid. Now we are coming to the lateral surface area of cuboid. LSA of cuboid. Okay beta. So LHS of cuboid means in which top and bottom will not be included. For example, we have taken this as example. Okay, here top and bottom will not be included. What was the area of top? Length into breadth, and same area will be, its bottom will be length into breadth, means length into breadth part will not be included. So remove this length into breadth. Okay, so lateral surface area of cuboid is equal to area of four faces without top and bottom, without top and bottom. Okay, so what it will be, beta? This top and bottom face will not be included. It will become BH plus HL or plus HL. Okay, so it will be 2BH plus 2HL. So what we will take HH common, 2. Okay, now 2HH common take, or it will become length plus B. So 2 length plus breadth multiplied by height, and this formula you have learned in the earlier classes also. Area of 4 walls of the room. Area of 4 walls means at that time top and bottom will not be included. जब आप उसका लेटरल सरफेस एरिया निकालते हैं तो उस समय आप क्या करते हैं बेटा, टॉप और बॉटम को नहीं इंक्लूड करते हैं। और इसको आपने अर्लियर क्लासेस में इस फॉर्मूले के किस तरीके से पढ़ा था कि एरिया ऑफ 4 वॉल्स क्या होता है, 2L plus B multiplied by height. Here in which form I have written 2H, and you can write it as also 2L plus B multiplied by height. Okay, if suppose only one face is there, if suppose only one bottom face is there and top is not there, so at that time top area will be removed from this formula, as I taught you in the case of cube. So when we will come to the question, at that time we will understand that one also. Okay, now finally we are coming to the volume of cuboid. Okay, volume of cuboid is equal to, beta, it is a 3D object, it is having length, breadth and height, so its area will be, its volume will be equal to, okay, volume of cuboid is equal to, volume of cuboid is equal to length multiplied by breadth multiplied by height, meter cube or centimeter cube. So it depends on the question that in which form, in which unit we have to given its length, breadth and height. So volume of cuboid will be length into breadth into height, meter cube or in centimeter cube it will become. Because why it will become in meter cube or centimeter cube? Because length will also suppose in meter, breadth is also in meter and height is also in meter. So meter into meter into meter, what it will become? Meter cube. And in the same way centimeter cube also. Okay, so here beta, whatever the 3D objects you are in your syllabus, for them all the formulas we have covered in today's class. Okay, now from the next class beta we will start the exercise for this chapter. Okay, till then have a good day to all of you.